You're listening to PostgreSTAC 2022, brought to you this year by Crunchy Data, home of professional enterprise Postgres support and makers of Crunchy Bridge, cloud Postgres service for the discerning nerd. So, take over the screen, Mr. Bittner. Intro to PgSTAC. Looks good.
Windows around though. All right. Is there any way you can still show the Zoom window on a different window?
Oh, yeah. Don't worry about it.
Doesn't matter. I won't worry about it.
Okay. Take it away.
All right. My name is David Bittner. I work with Development Seed, doing a lot of development, particularly kind of database and backend development. And today we're going to talk about a project that I've been working on called PgSTAC. Before we talk about PgSTAC too much, I want to start a little bit and with just the stack part. Stack is a metadata specification on the spatiotemporal asset catalog that provides common structure for describing and cataloging spatiotemporal assets. Spatiotemporal asset is any file that represents information about the Earth captured in a certain space and time. So within the stack specification, there's really kind of three tiers that we look at. Sort of at the basic level, an asset is anything that has a URL. It could be a cog, it could be a thumbnail of a piece of imagery, it could be other metadata that's not being stored within the stack system. It could be JPEG or GeoJSON, it can be raster or vector data, it can be anything that has a URL. An asset is then stored within Stack as JSON that has a specific structure where you have, primarily kind of the three things that matter the most are you have your href, you have the URL, where do you find this asset? You have a title and description, and then you have a type. What is this thing that we're describing? And the roles. How do you use this particular asset? Assets that relate to the same thing are grouped together as part of an item. An item, there's no set structure. An item can be kind of anything that has the same space and time window related to what it is. It could be a Landsat scene. It could be a DEM product that was produced from lots of data pulled together that may have a time of when one sort of all the data, maybe a time window for when all the data could have national coverage. It could be global. It could be just a county. It could be a mosaic of land use and land cover. It could be a daily snow cover product. Basically, an item just needs to be some discrete unit that has a boundary, that has a spatial component and a temporal component. That temporal component could be an instant in time, or it could be a range in time that that item relates to. So an item in the stack specification is a valid GeoJSON feature that represents the spatial and temporal extent of the assets. So there's on top of sort of the normal GeoJSON attributes, the type and the geometry, there's also a number of other things that are required. What version of the stack specification, the ID, what collection, which we'll get to in a minute, it relates to, but then the bounding box, the geometry, the assets, which can be many assets. So, as we talked about, an asset for a satellite scene, it could have a cog asset along with a thumbnail asset and maybe, some additional metadata that goes into a lot of detail, about the whole production process of that asset. Those could all be assets that are part of the item. And then each item also has properties that the key of those is it must have a date time property that's an instant or a start date time and an end date time that describe a range. But on top of that, you can add many different attributes. So for NAIP, which is the National Aerial Imagery Program, it may be, what is the year of this collection? What is the cloud cover percentage of this item? For NAIP, it's generally grouped by, the product and what the assets cover, are statewide. So, NAIP would have a state property. And then your items are then grouped into collections. And collections are grouping of items that share common metadata. So you may have a collection that was Landsat, where then each item was a Landsat scene, from a particular window on a particular flight. For NAIP, the National Aerial Imagery Program, it may be a whole year mosaic for a given state. It could be, elevation data, point cloud data, census vector data, climatological data. A collection is just a grouping of those items that share common metadata. So again, STAC is built on JSON. And so a collection is going to have an ID, a type, different extensions, which are standard ways to describe different types. And so EO cloud cover is a common STAC extension. That's EO is a standard way to represent Earth observations. Description, title, providers, where does this data come from? What is the spatial and temporal extent of all the items? NAIP, that spatial extent is going to be just the US, whereas if it was Landsat, that extent may be global. Summaries can have statistics, aggregate statistics over all of the items. A number of links. STAC is made so that you can easily link back and kind of link through sort of the chain of collections and items, with self links and parent links and everything. And then there's some things, there's some other extensions like the item assets extension in STAC, which allows you to describe some of the common attributes that are in the assets within individual items. So what is PgSTAC and how does that relate to the STAC specification? So there's the STAC specification, which really describes how do you document this metadata. And there's also a STAC API specification, which allows how you can interact with STAC data and how you can do things like search for STAC records within a STAC system. So PgSTAC is an opinionated schema, functions, and triggers for Postgres using PostgIS to provide highly performant and scalable API for the storage and discovery of items in a STAC catalog. So PgSTAC really is how do we store that data and how do we provide some core elements to be able to search for data in the catalog. PgSTAC, we built a development seed primarily targeting the Microsoft Planetary Computer, which, as far as I know, is the largest public STAC catalog out there. We've also used it for a number of projects that we've done with NASA and various other folks that we work with at Development Seed. The planetary computer stack catalog, just as, when you're looking at what do we mean when we're scaling it, has 95 different collections with 87 million items. And within those 87 million items, it's referencing 1.7 billion assets. And those assets on the planetary computer are all things that then are sitting in internet accessible locations. And so STAC is not about storing, the imagery itself, the cogs or the thumbnails. It's providing the URLs, and the links to get to those assets. PgSTAC really tries to take a focus on just that storage and the search parts of creating a STAC API entirely at the database level, trying to keep the core functionality and the core abilities to search through STAC records as close to the data as possible. So PgSTAC does not actually create a STAC API. PgSTAC still is just database functions and a database structure. It still needs to be exposed through an API. Because it's just Postgres, anything that can talk to Postgres, any language that can talk to Postgres, you can create a thin wrapper in the API to then expose PgSTAC. A couple projects that are out there that provide this layer, the StackFast API, and this is the one that is used on the planetary computer that we use for all the projects that we do at Development Seed. And then the folks at Xavia have moved their Java-based Stack API to use PgSTAC as its backend. And so kind of a lot of that core logic, the storage and the ability to search is taken care of by PgSTAC, and the ability to kind of integrate and expose the API, provide that documentation, can be done through anything that can talk to Postgres, and it can be wrapped, to work with different languages or anything. Within the database, PgSTAC relies heavily on the JSON-B data type and functionalities of Postgres so that we can have a flexible storage of stack items. In particular, what this means is that PgSTAC does not actually provide any validation to the stack specification or to any of the stack extensions. PgSTAC can take any data that you put in as JSON, and it will store it. The only things that it really requires you to have as part is the date time and the geometry information as part of that stack record. It's parsing out and it's separating and instantiating as its own columns. Everything else is stored relatively as is in JSON. So when you are adding data to PgSTAC, you should always use something else on the way in to validate to whatever extensions you may be using or to the stack specification. There's a bunch of different libraries out there, PyStack, StackLint, that you can use to validate your stack items before it goes into PgSTAC. But PgSTAC is explicitly tries to be is relatively schemaless. This means that PgSTAC, as that schema updates, as new extensions are released for Stack, as different columns or data types are added, PgSTAC can accommodate it. PgSTAC's acting as a container that you can still put that data in without needing to worry about, oh, PgSTAC hasn't been updated to deal with this extension or that extension. What PgSTAC does do is it provides some tooling for data ingestion and partition management so that as you are loading data into PgSTAC, PgSTAC has some configuration that will automatically divide that data up into separate partitions within Postgres, and it will partition both based on the collection and then configurable partitioning on time. So if you have, for Landsat, we partition it kind of temporally at a monthly level, but then kind of by all the Landsat data is separated, whereas something that's like NAPE that's updated much less frequency, we only have a partition for the collection itself, and there's no separate temporal partitioning. It does this and it gives you that configuration because with Postgres and partitioning, you really want, there's a sweet spot. You don't want to overly partition all of your data such that the planning and the work that it takes Postgres to figure out how to get to that data is too cumbersome, but you want your partitions small enough that you can easily chunk and easily manage that data. PgSTAC also takes care of helping you, it has some helper functions to create the appropriate indexes that you need to be able to search for the data that you need to search for. PgSTAC then exposes search function to enable searching of that data, and doing that searching in a way that is optimized and is close to that data. So somebody who's writing something in Java or Node or Python doesn't need to move a bunch of data from the database to the API server and do further processing. It tries to do all of that heavy lifting at the database level. You've heard me talk about the STAC API kind of has different extensions for different functionality. And PgSTAC exposes functions to provide search and filtering, forming to the latest release of the STAC API, including the fields, sort, context, filter, and query extensions, which are kind of all the main fundamental core extensions in the STAC API specification. The filter extension extends the OGC, or allows the use of OGC CQL2 JSON expressions to search items using spatial, temporal, and other operators with a high level of expressiveness. This is the same specification that is now also being adopted as part of the OGC features specification, and the same language that's used there. Here's an example of how you would do a search in PgSTAC. The search is returning a JSON feature collection. And an example of a CQL search, the filter statement, which you can have nested kind of the conjunctions, the ors or ands, as well as different operations can be nested as deeply as you want. And so this particular query would find everything that has either less than 20% cloud cover or that intersects a particular geometry. CQL2 has spatial operators, it has temporal operators, it has array operators where you can use kind of to make as simple or as complex of a search as you want. The search function also takes a number of other standard arguments. You can provide sorting information for sorting that you want to do, limit on how much data to return. And there's also some basic things, so you don't have to build the entire CQL filter if you just want to filter by a date time range or a bounding box or a geometry. PgSTAC also has a few other tricks up its sleeves, but besides just sort of that, the storage infrastructure and the partitioning infrastructure, to try to, again, do some things as close to that data as possible and to make those searches as performant as possible. The one thing that it'll do, so you saw the difference between, we had on the planetary computer, we had 1.7 billion assets for 87 million items. That means we've got some monster JSON that's getting stored. If you use the item assets extension at the collection level, if there is kind of redundant information that's the same for all items across a collection, PgSTAC can strip that data out when the data goes in and rehydrate that data when you're returning the results from a search. So it can drastically reduce the size of data that's getting stored in the database. Other thing, because we have a heavily reliant on partitioning infrastructure, the biggest use case for STAC, or one of the largest use cases, is when you want to run a very complicated filter and then sort by date time. Because our partitioning has that date time component, what we do is, rather than, a lot of times the Postgres query planner, particularly when we're dealing with geometry, with PostGIS operations on geometry, combined with some pretty heavy JSON-B operations, the query planner has a lot harder time getting the right statistics to create a good plan. And so what PgSTAC will do is, rather than kind of just making a query that goes against all of the partitions, we know that if the data is sorted by time, we can kind of run the query serially, a partition at a time, until we've reached the limit, or the number of the number of records that we want to return in a given page. And so this optimization can make a huge difference in performance. The other trick that PgSTAC has is it provides a geometry search function. So if you're interested in this, the easiest way to kind of see how that geometry search function works is that's kind of what powers T-Tiler PgSTAC, which allows to create dynamic tiles directly from the results of a STAC search. So what that means is, if you create a search against a STAC catalog, say you wanted the most recent imagery that had less than 10% cloud cover, and you wanted to show that on a map, show kind of the geometry search will let you filter based on a passed-in geometry, which could be an XYZ tile, which is kind of how T-Tiler works. What you can do is you can register your search and then use a hash for that search, basically a key. You've said, hey, here's the search I want to do, get a key back, and you can pass that key in and only return the items based on their geometry and the ordering that you requested that would be visible when you were displaying that geometry. It's kind of hard to describe, but so basically, if we had 4 items and they were ordered by the number that we have on this item, and we pass in a search that returns those 4 items and a geometry, that's this big outline here, the black outline. If we were sorting ascending by the number, in this case, we would only end up returning in what we return from that geometry search, the numbers 1, 3, and 4. Because we would first pull up 1, we would see okay, we haven't covered the entire square yet. So we'll go to 2. It would look at number 2 and say, oh, wait, that's going to be hidden completely under 1. So we don't need to return that. Return 3. Oh, there's still a corner that's left, and it would return number 4. If we were to order by the number descending, it's going to say 4. Okay, there's still part that's not covered. 3, there's still not part that's not covered. 2, there's still part that's not covered, and then 1, and then it would return the data. And so in this case, all 4 of those items would be returned. So this can be really useful for things like creating a ZXY tile, such as ttiler PgSTAC does from search results. And as I said in the example earlier, to make a mosaic, this allows you to do things to make, like making a mosaic of recent imagery with less than 10% cloud cover. And that's really sort of the whirlwind tour of what it is that PgSTAC does. There's kind of a number of other things it does to really try to optimize kind of how the queries are run, how you can search that data within PgSTAC or within a STAC catalog. And that is kind of all I have. And so if there are any questions that are out there.
Yeah, are we going to have a community build of PgSTAC in the near future? Apt install Postgres 15 PgSTAC?
So because most of the uses that we've had for PgSTAC are almost always using a cloud deployed database, so using Azure Postgres, Postgres Flex Server or Amazon RDS, like most of our clients and most of the, what's been funding development seeds work on PgSTAC has had that use case. And so PgSTAC actually comes with a Python utility that helps with data loading, but also, is used to run migrations. And so, I would say kind of for the community build, probably the first target, if we were to really look at something like that, would be to use the Postgres extension system, and then once there was a Postgres extension system, for PgSTAC, then, look at kind of using something like apt install Postgres. But right now you can pip install PyPgSTAC and PyPgSTAC migrate will kind of automatically load PgSTAC into a database.
So is PgSTAC being run in production? Like, who are the big users?
So there's a lot of users that we were just at the SAT Summit a few weeks ago, and a lot more people using it than I even realized. But for the work that we do at Development Seed, we've been heavily supporting the Microsoft Planetary Computer. That's been sort of the biggest driver of PgSTAC, but we're also using it for a number of NASA projects. Mercy Corps, has a new project out that's using PgSTAC, and a heck of a lot of people that I was surprised kind of where it's ended up, but it's being used very heavily in production.
You arrive at the right time with the right tools, people want to use it. So I feel like I have to ask this. Probably Greg will administer a beating to me for asking it, but it must be asked. So you've got this collection of JSON documents, nested collection of JSON documents. Why is this not MongoStack?
So a lot of the early pushes, were not Mongo. Elasticsearch is kind of the big, I think the the biggest competitors, that the PgSTAC has are kind of more targeting, something like Elastic. And, honestly, I've been using Postgres for 20 years, and,
Yeah.
a lot of it comes down to, hey, this is the tool that I know very well. And, it allows, much more transactional control, than kind of some of these eventually consistent platforms. But yeah, at some point it's this is the tool I know really well, and that has having the expressiveness of the spatial operators that is provided by Postgres is huge.
Awesome. Okay. Thank you very much, David. We're gonna